Welcome to part 2 of the timer series. Here you can learn WPF and C#. In the tutorial we are going to program backend for a timer using C# code. So let's update the program's version first. We will start with declaring private members for the use in our methods. We are going to need int variables for minutes, seconds, and hours. Don't forget that private members are commonly named starting with the M prefix. Then we need a boolean field indicating whether the subtimer is working or not. Of course, we will need timers. For that we are going to use dispatcherTimer class from the threading namespace. Press Ctrl dot and hit enter to include the namespace. We will also need a boolean variable which will tell the program if it should store time values before it starts working. Let's give it a summary to make it descriptive. And sure thing, we need variables to store that before launch time. Declare 3 private int variables for the main timer which will store hours, minutes and seconds. That will be set before starting the timer. When the timer stops, either manually or because the time runs out, the text boxes will contain the time values which were set before starting. Also declare 2 private int variables for the subtimer which will store minutes and seconds. That will be set before starting the timer. We will add hours for the subtimer in future versions. Finally, we will make use of a notify icon. Bad news, it does not exist in WPF, but we can borrow it from Windows Forms like this. Right now, our project doesn't know anything about Windows Forms. So let's include it in project's references. Right-click on References and select Add Reference. Make sure that you are in the Assemblies Framework tab. Scroll down until you see system.windows.forms. Check the checkbox and click OK. Now we can use it. When our program starts, we should set up our timers, namely the tick event and interval. Press Ctrl dot and hit enter to generate this event. We'll deal with it later. Now we need to set the interval which defines how frequent ticks are. With this interval, the tick event will fire every second while the timer is working. Let's do the same for the subtimer. We will also display the program's version in the title on start. First, we need to get the version from our assembly. Now we need to set the title. Let's use string format method. You can type the keyword this to refer to this window, or just omit it. It does not matter. A window has a property called title, which is displayed at the top. We want to add the version to the existing text, so type plus equals instead of just equals. Variable types are similar to a class, in the sense that they have their own methods. One of such methods for the string variable type is format, which allows substituting text parts marked by curly braces with parameters set after the comma. This way we will always know the program's version. So let's proceed to coding the core of this timer program in the main timer stick event. I'm going to do it as follows. Because every tick is fired every second, we will first check if main timer's seconds are equal to 0. Then we check if minutes are also 0. And then we check if hours are 0 as well. So if everything is 0, we should disable the main timer. Then we check if the sound notification should be played. If so, we will play sound. The code for it will be in a separate method. After that, we should check whether subtimer should start. If so, we will set the appropriate boolean to true and enable the subtimer. But if subtimer shouldn't start, we will restore our view to look like on start. Set button stops visibility to hidden. We will also enable all buttons that were disabled not to interfere with the timer. In addition, we are going to set current timer values to those which were before launching. This is what you see in a common timer app on your phone. So this is what happens when all main timer values are 0. But if hours aren't, then we should decrease hours by 1. We will also set the textbox text property to this variable. But in a specific format. So if you want to always display 2 digits, type toString with 2 zeros inside of it. Then we set minutes to 59. and update the appropriate text box. As for the seconds, we need to set them to 60 because the next tick will decrease it right away. So don't update the seconds text box. Those were hours. Now if minutes are on 0, decrease minutes by 1, update the minutes text box, and set seconds to 60. So we checked every possible 0 value. But most of the time, we need to change seconds when there is no 0. So we only need to check if the main timer is still enabled. If it is, we decrease seconds by 1 and update the appropriate text box. As you see, we used if, not else if. That means that we decrease seconds even if values are 0, provided that the timer is still running. This way, you don't need to decrease them and update the text box in every possible branch of this event. One of the methods that we called when the timer stopped was enable buttons. Here we will enable both group boxes, and that will affect all nested controls. Also, we will make all text boxes editable by setting isRead-Only to false. Of course, if we have enable buttons method, there should be disable buttons method, which will be the opposite. So let's first duplicate this method. Just change all true to false and all false to true. Now we are going to code our start pause button. First, let's move it up. So when we click the button, we should disable our buttons. After that, we should store time values. Then we check if this is the starting launch and if we need to store pre-launch time values. If so, we store them. We are going to get main timer values from the 3 variables that we assigned above. As for subtimer time values, we are going to get them directly from the 2 appropriate text boxes. Of course, we will need to convert them to int32. and set the bool field to false in order to disallow storing current values if we continue. Then we check what was the timer state before pressing the button. If the timer wasn't working, we will turn it on and prepare the view. But we also should check if the subtimer isn't enabled and isn't working by using the AND operator with two ampersand characters. If both conditions are true, we will enable the main timer. Else, if the subtimer isn't enabled but was already started, we will launch the subtimer instead. Otherwise, we should pause the timer. In any case, we should make the stop button visible. So we set the visibility outside of those branches. All those cases related to when the main timer wasn't enabled before pressing the button. If it is, we will disable the main timer and set the text to continue. Unlike Start Pause button, the Stop button should be simpler. First of all, because we stopped the program, the next click on the left button will be only as a starting launch, so we should tell the program to store time. Also set the current time to 0. Then we are going to disable both timers. Don't forget to set M is subtimer in process to false. Also, we should hide the stop button. Restore time values and enable presets. Now let's code the subtimer tick. This is going to be very similar to the main timer stick event, and we could have just copied it, remove the hours part and just replace main timer with subtimer. But it's going to be a bit different, and I know that the logic of the main timer could have been confusing, so I'll do it again and explain in the process. Unlike in the main timer, here we shall first set subtimer minutes and seconds to our fields. Notice that these are the same fields that we used by the main timer. We are able to reuse these variables because the two timers never work at the same time. Then, just like in the main timer, we check if seconds are equal to 0. If so, we check if minutes are also 0. If it's true, it means that we should disable the subtimer. We also check if we should play the sound notification. And we reset our view. But if minutes aren't equal to 0, we decrease them by 1. In any case, we check if the subtimer is working. If it is, we decrease seconds by 1. Now let's run the program and check if it works as expected. Okay, now let's make parse info presets. As you remember, we gave each button a tag. Let's get it. We will access the sender as a button. And convert its tag to string. We used a dot to separate minutes from seconds. That's the first thing we will check the tag for. So if we have a dot, we should split the string by this dot and get a 2-element array. After that, we are going to set the text of appropriate text boxes using the parse method of int. After colon, you specify the format. D2 means 2 digits. You might have noticed that some of our code uses D2 and some of it uses 2 zeros. Both are being used to convert numbers from 1 digit into strings with 2 digits. That is, strings where the numbers from 0 to 9 have a leading 0. In this case, both of these methods do the same thing. The only difference is that format D2 accepts only integer type values, whereas format 2 zeros would work with floats or doubles as well. Otherwise, if there is no dot but a plus, we again separate the tag by a plus and write two values to a string array. Then we set the text of appropriate text boxes using the parse method of int. It will be faster if we duplicate our code from parsing a dot and then change it as we need it. Presets with the plus will only set minutes for the main timer and the subtimer. So set seconds to 2 zeros. Note that we do not change hours at all. But if we have neither a dot nor a plus, that means we have only one number. Such tags are only present in the first few main timers presets. The implemented parsing depends only on the format of text. So when you think about the future format of data or even a language, think about how difficult it will be to parse it. Also, avoid using ambiguous separators. For example, don't use a dot to indicate both the separator for time values and different timers. So please subscribe and see you later.